I'll record now. So you'll see this, right? We have 40, K, 19. Are we doing alpha? All right, so what you're going to see next, so the question may be something like this. What element will be created with the alpha decay of potassium 40? Right? What element will be created from the alpha decay of potassium 40? So you're going to see potassium 40. This is the element, right? It's 40. 19 is the atomic number, which tells me that it has 19 protons in its potassium. So what you're going to see next is an arrow, right? We're going to figure out what's it going to break into. So we know it's going to break into. Here's the symbol we're going to write next. All right, we're going to see that symbol next. All right. You're going to see a plus sign. This is how we're dealing with an alpha decay. Okay. So if I told you this already, this number is going to decrease by 4. So if this number decreases by 4, what am I going to end up with? Somebody. If the mass number decreases by 4, what am I going to end up with? 40 minus 4?
36.
36. All right. This number is going to decrease by 2. So what's that number? 19 minus 2 is?
17.
17. So now tell me, what element is that? All right. So now I have 17 protons. What element is this? What element has 17 protons? I don't have to edit my video because you guys can't figure that out. That stinks. Look at your periodic table. What element has 17 protons?
CO.
Cl, which is chlorine. All right, so I'm going to end up with... So I started with potassium 40. It underwent an alpha decay. I end up with chlorine 36. All right, that's the alpha decay. That's how that works. All right, so the next one we're going to talk about, so it's chlorine. All right, you see that. So the next one is the beta decay. Beta negative decay. Beta negative decay. So that's the symbol for beta negative decay. So I'm going to erase this. All right, that's the symbol for beta negative. All right. So we're going to do the same thing. So we're going to ask this. So what would be the beta negative decay of potassium 40? So I'm going to put potassium 40 back on the board. All right. And we're going to go beta negative decay. All right. So again, you're going to see an arrow, right? This is important. That arrow placement is important. So we're going to have it beta decay, and you're going to put the symbol in here, which is 0, E minus 1. All right, plus. So we said the mass number is not going to change, so that's going to stay 40. Okay? This in a negative, and this is where it's opposite, in a negative, in a beta negative decay, that's an A, beta negative decay, this is going to increase by 1. This is going to increase by 1, so this is going to be 20. So what element is that? What element is 20?
CA.
Ca, which is calcium. Okay.
I just can't see the word.
Beta decay. Oh, on your periodic table. Got you. So, right. So potassium 40 undergoes a beta negative decay. It turns into calcium 40. All right. So that's how that works. All right. So now we're going to go with a beta positive, and I'm going to write that on the board too because there's something I want you to see that's different with that. All right. So in a beta positive, the symbol's the same. We're going to start with this again. Right? So the difference here is this. In the beta positive, you're going to see the plus sign and then the symbol before, and then the arrow. So you got to know where the arrow is, right? Over here you have the isotope symbol and the arrow. Here you have the isotope symbol, the decay symbol, and then the arrow. Okay? That's beta positive. All right? So know that. That's important to note. All right? That's how you can tell the difference between the two. All right? So in this one again, that doesn't change, but in a positive, this goes down by 1, so it becomes 18. And that element ends up being argon, Ar. Okay? All right, so that's important to note there. So I'm going to turn off this video.